Okay, we shall get started, people. Can you hear me? Just a little yes in the chat would be good.
Yes.
In real life.
Yes, awesome. Bryan? Oh, this isn't that. Thank you. All right, welcome to Sydney Modern Apps Meetup. Welcome back. After 2 years plus online and not meeting up, we're here in person, so welcome back. That's me. Sam Sutherland, there's my Twitter and my LinkedIn if you want to keep in touch after the event. So a little bit about me. I've got sort of 16, 17 years in software development, .NET, WPF, web services, SQL Server, Oracle background. And then more recently moved into modern applications, cloud, Xamarin, and Flutter development. My good colleague Michael, Xamarin MVP, has handed over this group to me, so I'll be moving this group forward in the future and organising more events like this. So anyone that's keen to speak, that's got ideas they want to share, I'll be pleased to hear from you. And our speakers tonight, Bryan and Luke. So Bryan is a senior developer at Microsoft MVP for developer technologies and now Azure as well. Congratulations, Bryan, for about this week. There's his LinkedIn if you want to follow him. And he will be presenting an introduction to Azure Container Apps. And then Luke Moody, senior developer and Flutter technical lead at the Flutter Co. And that's Sam. That's his Twitter, and he will be presenting Accelerate App Development with Mason. Well, Bryan, over to you.
Okay. So, thank you, Sam. Hey, guys. Okay. Good evening, everyone. Hope everyone's having a great time. Today, or tonight, I'm going to talk about Azure Container Apps. So, Sam already introduced me, but let me introduce myself again. I am Bryan Garcia. I'm a senior developer at SAM Consulting, and I'm also a Microsoft engineer for Azure and developer technologies for 6 years. And now I'm here in Sydney for just a visit, actually. I'm actually from the Philippines, so we have an office in the Philippines for SAM Consulting. So, yeah, I'm here for only a month and a half, and I'm also, you can follow me on using this Mind of AI on LinkedIn, Facebook, Twitter, and everywhere. Yeah, before we start talking about Azure Container Apps, I just want to ask, raise of hands, who among you guys have heard of Kubernetes, including just now? So, everyone, all right. Question number 2. Do you know how Kubernetes works? So raise your hand. So maybe you understand how Kubernetes work. Yeah, I think Michael does.
Well, it depends on how deep you want to go.
I mean, understand it on maybe a base level. You just to understand. Okay. Oh, guys and things. How about you? Yeah. Okay, yeah. So I'm assuming my next question wouldn't have much. I don't think a lot of hands will be seeing this time. But do you know how to use Kubernetes? Do you know how to set up a Kubernetes cluster? Probably only a few of you guys can answer yes and can raise your hands. But then again, yeah, it was mentioned that Kubernetes is a container orchestration tool to abstract or that abstracts how when and what containers are being run, or even where actually. So that is just again the I'd say the definition of it. There are a lot of definitions of Kubernetes, or explanations of what Kubernetes is. But we're not really talking about just Kubernetes now. We're talking about Azure Container Apps. But this is important because, including me, it's very hard for a lot of people to understand how Kubernetes really works, and also even how it can actually implement it in your application, in your application. So even for the people who knows how to use Kubernetes and been in the Kubernetes journey for long enough, they probably have realized that there's a lot of how do I say it, operational complexity to maintain and to manage Kubernetes at scale. And for a long time, it's not just a single person. I don't think it's a single person's job to manage and maintain it. And so it is very, even my friend, I have a friend who's been using Kubernetes for a long time, and even mentions that sometimes he doesn't really want to recommend Kubernetes anymore, even if it fits the use case, just because there's a lot of complexity. There's a lot of operational complexity that is needed, and overhead, a lot of those things. So it's not that I'm hating on Kubernetes, not at all. I think that Kubernetes is a great thing. For the past few years, that's one of the best things that I've seen, and I would love to use it if I know how to use it. And that's the problem. It's not that it's bad. It's just that people are having a hard time understanding and making it work. So, I feel like if there is a service or a product that can alleviate those pain points and complexity, that would be very nice, right? And that is where Azure Container Apps comes in. So Azure Container Apps is powered. It brings the power of a full-blown Kubernetes without having to deal with or having to directly access the Kubernetes APIs and having to deal with all those operational complexities. It allows you to, or it provides or handles the provisioning of resources, the scaling up, scaling down, routing, all of those stuff. With with the help of them having to deal with the underlying Kubernetes API and abstracting it from you. So you don't really have to deal with these APIs you would usually deal with if you use Kubernetes. So it's very different. You're just basically gonna deal with it like on a portal, and you probably just type in something. Later on, you will see it. But to give you more details about Azure Container Apps, again, it's powered by Kubernetes. It is fully serverless. So this one is one of the best things about Azure Container Apps. Have you heard of Azure Functions? So if you've heard of Azure Functions, it's pretty much like that. So you only pay for what you use. You only pay when you use it. So it can scale down to 0, meaning if no one's using your Azure Container Apps or accessing it, you're not going to pay for anything. As long as you set up the scale to 0, and later on we can I'll show you that. And then apart from that, you can also use you can also implement a fully managed Dapper into your Azure Container Apps. If you've used Dapper, later on we'll talk about it as well. But it gives you the power to implement some of the microservice features that you would like to have in your microservices, and this helps you make it easier to implement. Later on, you will see it. Another thing is auto scaling. So this is one of the best things as well, because you have 2 options. If you have like a web application, an HTTP based container, you can auto scale it using that. Based on the concurrent requests, you can scale it up to maybe 2 instances, maybe 3 instances. That's not a problem. You can also use EDA or Kubernetes event-driven auto-scaling. So what does that mean? You can base your auto-scaling on source scalers like Azure Application Insights, Log Analytics, and a lot more. So we're not really going to dig deep on that one, but that is one thing that Azure Container Apps has. You can also deploy public and private container or container images from these container registries. So it doesn't matter if it's public, doesn't matter if it's private, if it's coming from Docker Hub, doesn't have a problem. If it's coming from Azure Container Registry, way better or much better. So yeah, it doesn't matter where container images come from, it can handle it. And then you also have container revisions. So this one is, for example, you have new versions of your image and you want to update your container app into that image, you can create a revision of that. And what you can do on top of that is you can do a blue-green deployment wherein you can only give 20% of the traffic on this new version and keep the traffic on the previous version, like 80% of it. So you can, you can monitor and see if the new version is doing well, all this stuff. Later on, I'll show you that as well. But anyway, when it comes to limitations, we have two limitations. You have no root access on this one. On Kubernetes, you can do all of those if you want, but for Azure Container Apps, you can't. And this is only Linux-based. So you can only deploy Linux-based containers, container images here. But if you're a .NET developer, you don't have to worry because .NET runs on Linux. So no worries on that. So how does it compare to our or Azure container options? So you might have heard of some of these options. First one is having a Kubernetes running on an Azure VM. So it's just a plain old Kubernetes running on the cloud using an Azure VM, a virtual machine. So it is more complex, basically, because you're still using a Kubernetes, a plain old Kubernetes just on a VM. And then on the most simplest side of things is a container instance. So what is a container instance? Container instance allows you to run a single instance or a single isolated pod, and you can deploy your container image if you want. So you will pay for by the second, I think, if I remember correctly. But yeah, that's the most simplest one. If you just need your container to be up and running quickly, you can use the container instance. Then you have the app services. So app services is optimized for web applications. It's not really, focusing on containers or microservice features. But if you have like a container image that is mainly for web applications, you can use that. You can deploy code for container images and app services. And then you have the Kubernetes service for the Azure AKS, Azure Kubernetes service. So this one gives you a fully managed Kubernetes, but you can still directly access the APIs. So it's just basically having a Kubernetes in Azure, but it's quite different. In my experience, it's not the same, exactly the same as Kubernetes on your computer, on your VM. They have like different terms, different, it's a bit different from what you usually get on Kubernetes on your machine. But anyway, that makes things easier for you as well, having the AKS set up. But you can still access the root, you can still have direct access to the APIs, and that is what is different, or what basically the difference between Kubernetes service and all of these with the container apps. Now the container apps, yes, it is powered by Kubernetes. It provides you a full-blown Kubernetes type of microservice and gives you the best practices, but you don't have direct access to the API. Some people may say that it is a good thing. Actually, it might be a bad thing for some, and that's the reason why you have these other options. But I would say it's a good thing, and at the same time, it makes things easier for you. So you don't really have to think about those operational complexities. You just focus on developing your app. And that is what container apps can give you. You can deploy multiple containers in that in a single container app, and it gives you all of the power. It gives you all of the things that you might need to run a container and to run distributed apps, microservice. You will see it later. I'm going to be doing a demo later, but before that, let me give you some of the use cases where you can use Azure Container Apps. So first thing, well, obviously, microservice is the main use case, but you have these other use cases too. You have the public API endpoints, which, as mentioned earlier, you can set up blue-green deployments. And what this does is it gives you an ability to set up these HTTP APIs, or maybe just a website, may it be internal or public, and create versions of it and split the traffic on all those versions if you need, or just active versions actually. If you have, let's say, a website and you create a new version of that website, you can create another revision of it, and you can split the traffic maybe 50-50 or 80-20. So it depends on how you would like to make that work. So you can split the traffic on multiple revisions, and I will give you a demo of it later. You can do background processing if you want to, create a container that runs background processing, maybe storing data into your data store, or maybe an event-driven processing if you need to. But the most important thing is microservice. With the help of the fully managed Dapper, you can easily implement or easily set up a microservice, set up microservice, and you don't really have to kind of like deal with the underlying stuff. So later on, I will demo this one and the first one, the public API endpoints. Now that you understand what are the use cases and what Azure Container Apps is, now let's talk about what is inside an Azure Container App. Well, actually, it's not just inside the container app. On top of the container app, we also have environments. So what are environments? It's basically an isolation of a collection of container apps. So we have container apps, these are container apps, and you can have multiple container apps, and it's going to be within an environment. So what is an environment? So if you've heard of, if you've used Azure App Service before, you have an Azure App Service plan. So it's inside an App Service plan. It's kind of like a computer. You have a machine, and it has a compute power. Like let's say it has 8 gigabytes of RAM. It has this amount of compute units, and you can have multiple websites in there or web applications in there, and it will share that compute, and your web applications will share the compute power of that app service plan. So you basically have a container of your web applications, but this time this is called environments. It is still a boundary. It's still a kind of like a container of your container apps, but this time it allows you to set. It doesn't. You don't have to set your compute power on the environment. Instead, you will still have to set up the compute power for each container apps. So apart from that, what you can do with environments is you can set up these Dapper components. So later on, again, this might not make sense right now. Dapper components, all these things. But later on, I will show you how it works. But anyway, so I was talking about container apps. So container apps. Underneath the container apps, we have, again, revisions. So we have new versions of your image. You can create new revisions of your containers if you need to. And underneath those revisions, you can have replicas. So replicas is what is being created if you set up auto scaling. So let's say right now we have a single replica, and let's say 1,000 people opens your website, accesses your website. And of course, it needs to auto scale. It needs to scale up or scale out because there's a lot of requests coming in. So there's going to be an additional replicas, and you can set the amount of replica that you want. So maybe 1 to 5 replicas, as long as you have as long as it hits the metric that you need. Let's say every 100 concurrent requests, you need to create a new instance of your container, so it will automatically create a replica. So you can have like maybe 10 replicas of your container apps. That would mean you have 10 instances of that web application, that container. So yeah, and inside the replica, you can have multiple container images running. So it's not just a single container. You can have multiple containers running inside a replica. So I will show it to you later how it looks like. But anyway, let's go to the pricing. So how much is it? How much is it? How much do you need to pay for an Azure Container app to run? Actually, you can set it up, and you can pay up down to even zero. So you don't really have to pay anything, but that would depend on how you would use it. So of course, they have a free tier right here that they give you every month. So we have 108,000 BCPU seconds that it allows you to consume, and you don't have to pay anything. And for the memory, you have 260,000 gigabytes, and yeah, that's seconds. So it is given to you. It's just like an Azure function. You almost pay like nothing actually if you don't if you don't really have like this big application you're running. Not many people are trying to access it. You pay almost nothing. And of course, if you have like an HTTP based container that's running, you have 2 million free grant per month. So 2 million accesses on that container app running, you wouldn't pay anything. So of course, if you have an idle usage price, if you have a single instance running, you will have to pay for this if it's just there. But again, we have a zero scale, or it scales to zero. So we can, if no one's using it, then you wouldn't pay for anything. So it scales down to zero. There will be zero instance. So I know I've said a lot of things. A lot of things might not make sense yet. So let's now go to the demos. So let's share my screen. A second. So there we go. So this is the Azure portal, and what we want to do now, as you may notice, I have already something prepared for my that I did for testing. But what you can see here is we have container apps. Yeah, I need to zoom in a bit. There we go. We have container apps, and we have container app environments. So there are two separate things. So just like an app service and an app service plan. So we cannot create an environment. We cannot create just an environment. We need to start off with creating a container app. So we need to create a container app. So by creating container apps, by searching container apps right here, you can search for it right here, container apps, and then there we go. Will pop up, and you can just press create. But now we have this. So first thing that you notice is, of course, it requires us to source group, and that is normal for every Azure service. So let's create a new one called SCA RG, Sydney Modern Apps RG, and you have to give our container app a name. So let's say SCA container apps. Container app. Now we can select a region. So region is very important. If you're running, or if you have like your users are going to be in, let's say in Europe, of course you should select something near Europe. So maybe West Europe, North Europe, but we're now here in Australia, so let's pick Australia. And then this is what I was talking about. We need to create an environment this time. So an environment, again, is a container of all your container apps. So we need to create a new one. So creating a new environment would require you not only the name, but also if you want to set up zone redundancy and you want to make your container apps observable, you can set up monitoring, you can set up a log analytics, which you can see the logs, you can see the metrics that are happening within your container applications, and you can even set up virtual network. So if you want to connect it into a different environment, if you want to connect it in on-premise, so you can set up VNets for that. But we're not going to do this today or tonight. We're just going to set up our environment. Just going to give it a name, SMA container apps -env for environment. And we want zone redundancy. So you might ask, what is zone redundancy? So again, we selected Australia East earlier. So that is a region. So you have multiple regions. You have Southeast Asia region. You have East US region. And each of those regions have availability zones, meaning you can have if you disable this, you can only have your resource on a single availability zone in that region. So if you enable this, you can have multiple, you can have your resource in all three availability zones within that region. So let's say you're in Australia East, now you can have your resource will be set up on all three availability zones that the Australia East would have. So that might be like a data center. Yeah, you can have your resources on 3 data centers at the same time within Australia East. So that is how zone redundancy works. So you can enable this or disable this. I'm just going to disable it for now. And now we've set up the details, project details, our container apps environment. Now we can set up our app settings, our actual container app. So you can see here that we can use a quick start image. This means that it will provide us a hello world container image. And once we create this, we will be able to see our website, and it will just show a hello world website. But of course, we don't want that. We want to deploy something from our maybe an application that we develop. So we can untick this, and we can provide now a name for our container. We can select where the container image is coming from, maybe from Azure Container Registry or a Docker Hub. And you can select the registry and then chapter. And before we can set this up, first I need to show you the applications or the web applications that I have. So what we want to deploy. So what I have here is this Pokemon application. So what it does is it just shows all of these Pokemons here. It's not really all, just a few of them. But this is a website that is consuming an API. So this is the endpoint. It's still running in a local host. It's just a get action of retrieval of Pokemons, and how it looks like, or the code looks like. It's this. We have the API here. So it's just a single controller. We're just reading the Pokédex JSON file and retrieving all of the Pokemons within it. And that's basically it. It's returning the Pokemons within that. Yeah, it's just returning the Pokemons right here. So that is the Pokemon controller, the Poke API. Now let's go to our Pokédex web application. Now this is the front end. Now basically what I'm doing here is when you go to the index of the website, you retrieve the data coming from our Poke API, and it's just going to this specific endpoint and just retrieving all the Pokemons. And in our index CSHTML, we're just listing it down, all of the Pokemon. So the names, the image, and the type. And that's the reason why we now see it here. So this is the list of Pokemon that I have. So what we want to do now is we want to deploy this local host or this website and API running localhost into two separate container apps. So how do we do that? But first of all, we need to create an image. We need to generate an image for these two projects. So to do that, what you can do is, let's start off with the Poke API actually. So what we want to do is to create a Docker file for this one. So to create a Docker file for this one, let me show you, let me build this for you. If you're using Visual Studio, it is very easy for you to set up a Docker file. All you need to do is to right click on your project, then add a Docker support. And then you can select what you're targeting. If it's Linux or Windows, you can click it, and there you go. You already have the Docker file. And this is the only thing you need to generate a Docker image for this specific application. So now what I'm going to do is I'm going to right click and publish this. And I've already set up the publish profile. Nice magnifier this one. Basically, what I'm doing here is I'm publishing this Docker image into my ACA demo container registry. So I have an Azure Container Registry where I will deploy this image. And once I deploy this image into this registry, I can now create a container based on this image. So yep, that is basically how containers work. So now I've already actually deployed this because it takes time to deploy this. So I'm not going to deploy it. But all you need to do now is to publish this, and it will just automatically deploy. So now what I'm going to do is, we're still going to do the deployment later, but for the front end. But for now, we want to create a container app based on the Poke API. So I can just name it Poke API backend. This for my container, and I'm going to use an Azure Container Registry. And since I already have an ACA demo container registry, I can just select that, and I can pick the image that I have already published. Again, I've already published the Poke API, which is a Docker image. I can select that, and I can select an image tag. So tags are attached to images. So I'm just going to pick the latest image, the latest update of this image. I'm just going to leave it at that. And I have OS types. So only thing that we can use right now is Linux. And then you have command overrides if you need to override something. This is where you set up the resource allocation for your container. So you can set it up to maybe 2 CPUs or and 4 gigs of memory. But right now I'm just going to keep it using the default. And now, this the important part of it is that do you want to enable the HTTP endpoint for your container application or container app? So of course we want, because we want this to be consumed by our front end application. So I want to enable this, but you have this additional option to only allow the container apps to consume your API. You can allow it to allow your application to be accessed publicly, or you can only allow it to be accessed internally. So this time we're gonna set it up only internally. Now we just set up target port to 80, and it's always going to be an HTTPS, by the way, if you try to access this container app. But internally, we want to set up the port access. And now there's only tags to set up. So we're just going to skip that and just create. So with this, we're basically creating not only the container app, but also the container environment. So we're creating the environment where our container apps will live. So it takes a while actually. So we're gonna be discussing the Pokédex now. So this Pokédex is our front end. This is where our application or our API will be consumed. So we can go to the phone controller, and right here, of course, since we're not retrieving data from localhost anymore, we'll be using the API or the endpoint of the API that's going to be created. So just takes time. Right now, it's creating the environment. Might take maybe a minute or two. So, if you have questions right now, you can shoot it if you want to. Yes, sir.
Oh, what's the so on ACI startup time quite slow with 5 minutes.
I'm sorry.
On Azure ACI, startup time being quite slow, like with 5 minutes. You come on one new container. You said it's those container apps that close the startup time on container apps. Like,
You mean when you first try to access it?
let's say you're running a batch of on container app like 1 hour.
Oh, you want to run it every hour?
Yeah.
Yeah, it's well, it depends because you can always have an instance running. It's not like if you're talking about container instances, right? Compared to container instances.
Yeah.
Yeah, so it's quite different because container instances, actually, they're always up. They always again, you're being built by the second container app instances. But on container apps, you can set it up like an Azure function, which means you can have like 0 instance running, and then you can have an instance running when someone tries to access it. Now, what you can do is you can always have an instance running. It might be running on idle, though if you try to run Azure Container Apps. But you can always have this container apps running, and so you wouldn't really encounter any issues or cold starts. So it would execute quickly if you need to run maybe an hour job. So it doesn't matter. So it will run quickly as soon as you need it. So yep. I'm gonna show you that later as well. You can set that up to always be running, always on. Anyway, let's continue our demo. So it's now completed. You can go to resources. So this is now a container app. I can see my application URL here. I can see all of the other stuff that I can do. But let's do that, or let's discuss this later once we try and deploy these Pokédex front end. But again, we have the application URL here. Now, if we try to access this, you're getting this message that it cannot be found. Because again, it's only accessible internally. And you can see it in the URL. It says here the name of the container. It says here that it is internal. It is running internally only. This is a unique identifier that is given to our environment and the region where it's running and the domain of the Azure Container Apps provider. So this will always change depending on the region. This is uniquely generated or uniquely identified as generated. And this depends if you have an internal, if you have it running internally or not. And this is the name of your container app. So now we have this endpoint. We can now use this to consume our API. So I just need to paste this here. And this time, I'm actually going to deploy this. So I'm going to publish this. I already have a Docker file here. So I'm going to publish. And this time, I'm not publishing in the Azure Container Registry. Instead, I'm going to publish into the Docker Hub. So this is a publicly available Docker Hub. So if you try to look at this image, you'll find it in the Docker Hub. I'm just going to publish this. It takes 30 seconds. But anyway, while we're waiting, take maybe 30 seconds. Let's look at the container app and what it has and what it has to offer. So these are like default or basic Azure resources property or options. And then you have these settings. Like you can set up secrets if you need to store your connection strings, maybe keys for your if you have a third-party API or a service that you're using. You can set up contains deployment. So if you have like new updates in your image, you can set that up and it will automatically create a revision. So let's say you update your image, change something on the text or maybe anything actually. As long as you update the image, it will automatically be deployed. So you can also set up custom domains if you need to. You can set up Dapper components. This one is setting up the Dapper ID and port and how you can access this. And then you have the revision management that we'll later on talk about, and how you set up containers, or how do you want to, if you want to update the containers inside your container app, get revisions. Later on, we'll take a look at this, and how you would scale. Want to auto scale, what? So yeah, later on we'll take a look at that. But for now, we want to go back into our overview and go to our environment. So by clicking this, now I'm in my environment. I'm going to go to the apps to see all of the container apps within my environment. Now I can create a new one if I need to. And of course, need to, because we are now creating a new container app based on our Pokédex. So it's already successfully deployed or pushed. So this is the name of my container image that I have deployed in the Docker Hub. So now I'm just going to name this Pokédex container app. I'm going to have it deployed on Australia East, still on the same environment. And the app settings, I'm going to pick this and name this Pokédex container app, so we can have special characters. So we can select Docker Hub now, and since it's public, I can just paste the image here, which is mind.ai/Pokédex. And then we need to add the tag, which is the latest tag. And then I'm just going to keep it like this. And this time I'm going to accept traffic anywhere because we want this to be accessed publicly. And I'm just going to use the port again. And then this. So this is going to be a lot quicker because we're not just creating the container apps itself. We're going to create the environment, recreate the environment. So yeah, right after this, we can now try and access this front end and see if it's still retrieving. Here we go, it's already done. This time, we can have our application URL and try and access it publicly. So see if it works. There we go. So it's still running. And now this is running publicly. And where is the data coming from? From an API that is running internally. And again, I cannot access this publicly. It's because I can only access it if my container app is part of the environment. So I'm still getting all of these. So all good. So now I just want to show you some of the features that Azure Container Apps can offer you. Again, you can have revision management. What this allows you to do is to create new revisions and to split the traffic if you need to. So right now we only have a single revision. Obviously, we don't have anything else deployed here at a specific container app. So all we want to do now is to create a new revision. But of course, creating a new revision, we need to change something in our application, in our front end. So let's change the welcome Pokemon into welcome Pokemon fan. And it's just again, tiny things, tiny change, but this shows you that it's going to be a difference. So I'm just going to publish this again. It takes less than 3 seconds. I think it's almost done. So we can go back here now. And what we can do is we can give this revision its own name, suffix. So we can say revision 2. And we can remove this image and create a new one. And we can still name it Poke Dex container app, and still give it the Mind of AI Pokédex status. Still use the same CPU, and then we can just add it. So now I can create this, or I can go next and set up auto scale. So this is what I was talking about earlier. You can set up your auto scale. So this sample right here says that it can scale down to 0, meaning there's no instance running. Meaning if you don't have any users, it will give you 0 instance, meaning you don't have to pay for anything. Or it can go up to 10. If you have tons of users accessing your website, it can go up to 10 instances. So a single instance wouldn't handle all of the load. And you can set up a scale mode if you want. Meaning you can set, let's say, okay, this way you should be scaling up. So let's say, okay, I want to name this HTTP rule. And the type of scaling is, let's say, HTTP scaling. Now, every 20 concurrent requests, I want to scale up. I want to add another instance. So let's say there are 100 concurrent requests. That means that there will be, if I set this 20, there will be like 5 new instances created or replicas created. Because there is 100, you see, divided by 20, there are going to be 5 more instances added. So I'm just going to add this scaling or this scale rule in the created. So this is now deploying a new revision. So by default, when you create a new revision, that revision is the only one that is going to be available. But, okay, it's already done. I'm going to refresh this. So you can see it's the only revision that is available, the revision number 2. But what you can do is you can choose a revision mode and you can select multiple, meaning you can have multiple revisions running at the same time and you can split the traffic. Let's say only 50% on the previous one and also 50% on the current revision. So let's do that later. Now, what I want to do is let's try and access this again. This application URL should still work. There we go. And now, what I want to do is let's take a look at the console, because this is where we see how much replica we have. Right now, we only have 1. So I want this to scale up as soon as I try to access it multiple times, as soon as there are tons of concurrent requests. So I can only do that by running this JMeter. Not sure if you've heard of JMeter before. Basically, I can do load testing with JMeter. I can do an HTTP request specifically on this endpoint or this URL. And then I'm basically running 200 concurrent users on this specific or on this to this website. Now, all I need to do is to run this. And there we go. There are how many requests? Again, 200 requests running at the same time. So what this will do is it will trigger my HTTP scaling rule. So I can go back here, try and refresh this. And there we go. We're now getting more instances or replicas of this specific container app. So that means that there are now multiple instances of this, and it's now trying to handle that many concurrent users. So it will not slow down. We'll still be able to handle that many amount of users. So if I refresh again, should be more. Yeah, so should be up to 10. You see, we have 0 to 10 instances of auto scale. So yeah, it's basically auto scaling. Now, what we want to do is to do a revision management, and I want to set up multiple revisions. I can show the inactive revisions here. So this is our previous revision. So I'll try and refresh, taking a bit of time. We got a few more minutes. So that's hopefully this. probably taking more time than it should be. There we go. So now I can refresh this and I can activate this again and give 50 access for both revision. So meaning if I try to access this and this one and that one, I'll be able to get both of these, the welcome Pokefan and welcome Pokemon fan at the same time. So yeah, just taking time to set that up. There we go. So now if I try and access this on incognito, so probably the first one we get welcome Pokemon fan, and then the next one is welcome Pokemon fan. So this takes a while actually, and I guess it's just it's creating that multiple revision mode. So that's just taking a lot of time. Any questions, by the way, over the Oh, yes, sir.
I can handle lots of traffic.
Sorry.
So demonstrating HTTP can handle a lot of kinds of protocols for the traffic, or is it limited to that ability? So
Oh, it can handle it actually. There are multiple ways to handle traffic. It's just one of them that I've shown you. If you go to, let's say, scaling, HTTP is one of the ways to handle this. So you can edit this and go to scale and add a different scaling mode. So you can do custom scaling mode if you need to. It's different. It would depend on a different method. So even you can use an Azure queue. So probably not everything can be handled, but there's different. You can handle
I was specifically thinking it's like streaming with gRPC.
Ah, yeah. I think there's a different way to handle that, and probably that's where eval comes in. Kubernetes event-driven auto-scaling. Right now, I'm not really sure where we put it here, and I haven't really tried it. So that is probably one of the things to look at, how they handle it with Kika. Anyway, I think it's loaded already, so not sure if I just refresh this. We'll eventually get the Poke fan. But anyway, the point is, there's 2 revisions that are running now. There's a big chance that you might get either of the 2. But right now, it's just showing Pokefan for both of them. But Pokemon fan for both of them. But you get the point, right? So yeah, that is basically it. I would like to demo more actually. There's like a Dapper specific topic where you can use these fully managed Dapper services and integrate it into your microservices. And you can do state management, service and invocation, pub sub. And you can set that up with the help of a Dapper sidecar by setting up a Dapper component. I have it running already right here. Probably gonna show it to you. Basically, we have set up a Dapper component specifically for state store, meaning we now can handle state management with the help of an Azure Blob Storage. This means that in this storage, we can have within the container, we have this Dapper stored, and we are now storing this counter, which is now 202. But if you try and access the website, this website right here, and it is still the same application actually. It's just there's just an additional change here. But anyway, it's usually a problem handling. Yeah, probably not working right now. But yeah, the point is, there's a state management that you can use or you can implement into your application by using Dapper components. And it offers different kinds of services. So you can just search for Dapper. You have Dapper documents, documentations, so that's what it does for you, what it can give you. Components right here. You have the state stores, the pub subs, the what is it? Yeah, for this example, you have like list of state stores, and you can use any of these to set up state stores for your microservices. Like you can set up Azure Cosmos DB. For this example that I was supposed to show you, as a blob storage, and yeah, you can basically set up these state management for your microservice. But anyway, yeah, I think that is it for my demo. If you have more questions, if you want me to, talk to you more about Azure Container Apps, you can find me at Bryan of AI, or maybe send me an email, brian@sam.com.au. But yeah, thank you so much for listening. I hope you learned something. I hope you'll be able to use it in the future. Yeah, if you have any questions, you can ask me. I'm good at sitting down for any of stuff. Yeah, thank you so much.
Thank you, Brian. Do a quick changeover and then we'll do for Mason.
Cool. I'm just going to share my screen. Names. And I see that. Awesome. Right, awesome. So hey everyone, thanks for coming up today. So this talk I want to talk about a tool called Mason and how it can sort of accelerate your day-to-day development. So just very quickly though, a bit about me. I'm Luke, I'm a senior developer and Flutter technical lead at Zen and Developer. You can find me at Twitter, LinkedIn, GitHub, and also Discord. Thanks for put that up there. So you can chat about me to me about that later. But just a quick question: who here is a Flutter developer or has developed in Flutter before? Absolutely no one. That's great. So okay, then who's heard of? Thank you. Then who's heard
Well, Luke, I'm here, Luke. I develop Flutter apps for a living.
No one. Okay, that's
Luke, there's one online, NAG develops.
Yeah, NAG. Yes, awesome.
Apps for a living.
Thank you, NAG. But cool. So yeah, that's what I'm going to go over today. So there's four sort of topics, or three topics, and a question for the end. So first, we want to look into sort of where Mason came from, what is it, so help you, and also how to install it. Then we want to go through bricks, how bricks help, how they operate, what is a brick, most importantly. And then we have a demo which demonstrates just a feature of bricks called hooks. And that's also, we're going to combine sections 1 and 2, so we can sort of recap that in a demo. But first off, I just want to go through a quick scenario that you may all have been through before. So clients come to you and say, hey, we want to create a new feature, so for example, a login feature. And for most people, what you do is you go check your other features. It's like, okay, how do I structure this out? How does my team like to architect features? So we go through, we see, okay, this feature has a view, and inside of that view we have a page. Think, okay, so what state management do we have? And so, okay, we're using Block for this this application. Then you have to create all that and see how you're mapping your events to your states. And then you also want to abstract things because you want things to be easily testable. So you extract this thing to widgets. So they make a looking body. So just to sort of create all that, you have sort of all of these files just for the very stock standard feature, which can be tedious if you're going back and copying and pasting, which I'm assuming most people do. They go to feature, copy it, paste it, rename. So that's what Mason tries to tackle, is you want to be able to have these templates that you can just run. All this is here like dynamically as well. So if you do exactly what we just did with Mason, we'll get into all the terminology, but we'll say, hey, let's make a feature. Let's say it's called login. I want to use block for state management and a few other things, and then it takes 0.1 seconds to create a feature. So cool. So let's get into sort of what is Mason, where did it come from? So Mason is an open source Dart tool created by Filipino. Some of you, actually, none of you will know Philip. So he's also the creator of the mock package, Incredible Mocktail, and a few more, and also Mason. So what Mason does is allows you to create and consume custom templates that we call bricks, and it can be helpful to those of you who find yourselves writing the same code over and over again, or you want some sort of dynamic and customizable templates. So this is also what the company called Very Good Ventures uses on their own CLI. So this is what they use to create their own sort of opinionated version of what they think a project should look like, what a package should look like, what a plugin should look like, etc. So that's what we sort of want to do as developers. Is we want to say, hey, this is what my team think the feature should look like. So we should create this brick. So anyone not following can just run this brick and and then they have their feature set out for them. So yeah, over time we can create more sophisticated bricks, even a whole startup project if you wanted to, both front end and back end, just with one click, with also a lot of dynamic sort of values in there. So it is a very powerful tool. No specific language that you need a template for, would be anything at all. So before we get in, I would probably recommend looking into the docs. We will go into quite a lot of the stuff that's covered in the documentation anyway, but it's just there if you want to just go through a text version of what I'm saying. So there is a prerequisite, so we have to install Dart because it obviously is a Dart tool. So that's how you install it on Windows, Mac, and Linux. You can go to the Flutter website and see how to do it, but I've just downloaded it from there anyway, so same thing. So once we've done that, now we can actually install Mason and start using it. How do we do that? We call Dart pub global activate Mason, which is just saying, hey, I want to be able to use this in my command line, PowerShell, wherever. And then we'll get this. And just to check that you've installed it, you can just run Mason, and you should get a bunch of commands that you can use, like Mason -- version to check the version of Mason you run. So that's how you can install it. And now you can start getting started with it. So inside of your directory, you can call Mason init, and all that does is sort of just generates mason.yaml, which we'll get into, and also there's a couple of other folders. So .mason, again, you're not going to touch this, it's more like a cache, and same with mason log.json. The main thing we're going to focus on, and we'll be modifying is mason.yaml. So what is that exactly? If you're from the Flutter world, you can sort of relate it to your PubSpec YAML. If not, then all it really is, it's a file that defines all of the bricks you want to use in your project. So here we've just got a hello brick and a version of that. I put a note here that it is scoped to your project. So when you're using Mason, make sure that your project obviously has a Mason.yaml that it can refer to, or at least one involved in its parent directories. You can activate bricks globally on your machine, which we will get into in the demo. So that's also an option. So you are pretty customized on project-specific bricks. So defining a brick, there's a few ways. The first one is you can just use the name of the brick and the version. This will come from the registry brickhub.dev, and then you can find a bunch of bricks you may want to use. So that's one way. Another way is locally. So say you're developing a brick and you want to use it, or your team has a brick that's not published. You can just use a direct path from your directory. So my brick/hello is where my custom hello brick is. And then finally, you can also define through a Git URL. So if you are hosting your bricks somewhere in Git, You can then provide a path, and you can also actually provide a ref, a commit ref, if you wanted to. So now we've defined all the bricks we want to use. We can say Mason get, fetch all the bricks either from the registry locally or Git, and then it'll sort of say, hey, you have these bricks, version where it came from. So then you can go start using them. So using a brick is fairly simple. We'll just say Mason make a brick name, and what this will do is it will then execute that brick. Now this brick requires me to enter something. For example, it's my name, so I can enter loop, and then it generates one file, which is a hello.md file. So it's like your hello world, and you'll see, obviously, it comes up there. Something I forgot to mention real quick though is you'll notice we're in the C demos Mason directory. So wherever you run this brick is where it's going to get generated. So yeah, so then it's been outputted into there, and inside of it we have hello loop. So if I put hello anything, it would say hello anything. So obviously, like I said, it is generated in the specific file you're in, or the specific directory you're in when you run it, and that's where specifying output can be particularly helpful. So you don't always want to switch in and out of, like, say, a features folder to generate a brick and go out and generate another brick. So it's just, okay, let's define an output. I want my output to be example underscore project, same thing, loop, and then now it generated in that example project, as you see also the other one outside of it as well. So you can also specify variables in line with the command. So we've got Mason make hello. And we know this hello brick takes in a name variable. So we can say dash name is loop, and I still want my output to be in that example project. And this time it hasn't prompted me to say, hey, what's your name? Because given it. But you could probably imagine if we had 10, 15, or even 100 sort of inputs, that could get very messy, especially to make it dynamic. We have to type it all out. It wouldn't be practical. And that's sort of where brick configs comes into play. So all a config is a JSON file with key value pairs. So for example, I've got name, engaged running job developer, and that's it. That's all it is. It's just a JSON file. There's no real naming standard. It's just a hello config. It can be called anything as long as it's just a JSON file. And the brick would just consume that with the -c. So we're saying Mason make hello -c hello config, and then it uses that without again the config for anything, which is cool. So that's sort of how you consume bricks and sort of a general overview of Mason. But now it's probably best to know what exactly is a brick and how it sort of helps, and you can create one. So a brick has two main parts. It has a folder called __brick__, and it also has a brick.yaml, which, as I mentioned, it defines a few things: your name, description, version, variables, etc. And underneath our __brick__ folder, we have hello.md, so that's what we just saw previously when I generated it. But before we get into that folder, let's briefly have a look into brick.yaml. And as I just mentioned there, it defines everything about a brick. Again, if you're from the front row, you can relate it to prospect.yaml. Else, you see here, we've given it a name, there's a description, there's a version of the brick, there's a specific Mason environment you want your brick to run in. So say there's a bug in a specific version of Mason, like, okay, I don't want to run it there. You can select your environment. And I've also put a variable of name, so exactly like that example you showed earlier. I have put also variables, it's optional. Obviously, not every brick needs a variable, it doesn't need dynamic values, so you just have your boilerplate code without any change in there. So that's sort of your brick.yaml. The main part of it is this I was going to say brick folder. This is your brick folder, and this holds everything that will be generated when you run Mason make your brick name. So you can see here on the right, this is actually our accelerator we use at the Flutter code. It generates a full project with a lot of things already in place, like notifications and Firebase linking and sort of all the standard architecture. So I mentioned that you can have one project or one file or a whole project or 5 projects, depends how crazy it will be. And you can also have conditional files or folders. So it's not just the file content manipulation over, when we're using dynamic variables, you can also, say you have 50 folders, you only want to generate a subset of them depending on some value that was entered during the variable section, then you can do that as well, which we can definitely go over. So before we look into exactly what it looks like inside of a file, Mason uses the mustache templating, which, has anyone heard of mustache templating before? Okay, cool. Good. So just supports injecting variables, you can have conditionals in there, you can move through arrays. You can see this example here. It's fairly standard use as well. That's just the template. So using these variables, if we go back to our demo brick we had earlier, you see we have a name variable, which is type of string, description your name, default is dash in the prompt that we tell the user what is your name. And when they type in the name, we're going to use that over here instead of hello. Obviously, bracket name is going to say hello when they input. But not always does the user type in exactly the correct format you wanted. I could give a capital U and then like an L, lowercase L, etc. So that's where you sort of want to mutate these variables. And the way you do that is by using these inbuilt lambdas Mason supports, and all it really is you can use them to manipulate your variables. For example, here I've got upper, lower, snake, Haskell, and camel case, but you can see that this is all the current lambdas that they support. So if I was to run this now, I would get the correct output legally. So that's pretty much it. You've seen how we use Mason and how we essentially create a brick. So let's sort of create a service brick like here. So what do we need? We need obviously a brick.yaml to define this brick. So it needs obviously a name, it needs a default description, and it needs two variables. So I've fixed it, we need the name of the service you want to create. And we also want to give you the option of having a pre-generated method for whatever reason. So that would look something like this. Very simple name service. I'll go through all that, but then we have two variables, which is the main part. First one is type of string, second one is type of boolean. So then inside the brick, we are making use of those lambdas. So we set the service name, snake case, dot, and then the interface of that. So that's what I personally feel a service should look like. It should have implementation, the interface. And then inside of these folders, it should say inside the file brick. But I have some standard documentation. I'm also making use of another lambda, the Haskell case lambda, and just sort of throwing everything in there. I also have you'll notice that conditional now that has method. It's wrapped essentially some code I want to generate only if they've decided to get that to also method. And in the interface, it's pretty much the exact same thing. We've wrapped that method in as method variable, or boolean variable. So now if I was to run microservice, I would now get this service out with a very well documented service, pretty much. So that's that. I know we have some Xamarin devs here, so I've tried my best to create a very basic Xamarin custom renderer brick. And what this looks like is kind of the same as before, but we have, again, two variables, one name string, and the second one is renderer type. And this is type of enum. So obviously, as I mentioned, I haven't mentioned actually, it does support enums. So here I've said you can create an entry or a list renderer. You could have like 10 or 20 different controls here that you want to create a renderer for. So what I have here is I just have both iOS and Android custom renderers that take in obviously that dynamic name, and that's it. It's just to generate these two basic files. But can anyone sort of see an issue that may sort of occur with this specific template?
Maybe just thinking next spacing maybe.
That would be an issue in an actual project, yes. But let's say someone types in they wanted a 2-word entry renderer. So my space color, that's going to break everything because it's not going to be that sort of format we wanted. So to improve this, we have that .Haskell case lambda inside of that as well. So what would this look like? We say, hey, Mason make Xamarin renderers. was rendered name, color, and I want it to create a custom entry. And then our output, you probably guess, is just color entry renderer and all the stuff you were just seeing before. Now, you don't always want to use the command line to generate a brick or create a brick. So there is a concept of bundling a brick. And all this really does, it just shrinks the brick down into one file that you can then consume in, say, like a console application or some script you want to make or whatever. So we bundled our service brick, and there's just this very simple project that says, hey, I want to use the Mason generator, which obviously comes from the Mason package, and I want to create this bundle. And then that's it. So there's 2 lines of code generates that whole brick. So you could have like some scripting double click and say, yeah, it's done. You can inject variables from here as well. So you've noticed we said, hey, we want this current directory, but you can obviously have that as an input if you want as well. So that is cool. I guess we get on to a demo now. I'll just tell. There we go. Beautiful. Can they also see this now? Yes. Okay, great. Cool. Let me do it. See them. Okay. So we have our terminal now, and what we want to do is we want to create our own brick with also the concept of hooks, which I'll explain when we get into it. So first, let me just go into my bricks directory, and then let's create our new brick. So it's just going to be called demo brick. We can pass this optional argument of hooks to say, hey, let's generate this brick with the hooks there. So that has created our demo brick, and this is complaining actually. So we have everything I sort of mentioned before. We have our brick.yaml. We also have a few other things for if you publish a brick. Obviously, you want to have the change log, license, all that kind of stuff. But now in the slowest way possible. Cool. So we have our underscore brick folder, and this is exactly what we've seen before. Hello name. So what we want to achieve now is we want to use the concept of hooks if it wants to behave. Some packages out of date. Let's give. So there's 2 types of hooks. There is post and pre. I'm pretty sure you can assume which one it does what. So pre-gen obviously runs before the code is generated, and post-gen is after. So post-gen could be if you want to, say, run a certain script or a command in the terminal, then you can run that after. And pre, if you want to modify some variables or even add some more variables, you can do that in the pre-gen, which is what we will do. So pre-gen, what I'm trying to achieve here is I want to prompt the user to enter another variable, and then use that in my actual my template. So what it gives us, so we have this void run. It gives us the hook context, which gives us a lot of things. It gives us the logger, it gives us the variables, and that's actually it. That's not a lot. So it gives us the logger. So we can use this logger to then prompt the user again. So we can say, hey, let's confirm something with you. So we can say, are you happy? Okay. Say, I want these. So now what's going to happen is before we actually generate anything, we're going to ask the user if they're happy, or ask the developer if they're happy. And we can actually use the response of this in our variables. So we can actually modify this. So we have our context variables, which is what you see in the brick.yaml, those variables. And now we can say, okay, I want to use obviously the current variables, but I also want to now give another one. So I want to give one called isHappy. And this is now going to also equal isHappy. So just to recap, what I've done is ask the user if they're happy, and then store them now, adding to the current variables already there. So what we can do now is in here we can actually use this. So we use the mustache syntax to say it's happy. Whoa. And if they're happy, let's show you are happy. So if we run this now, first, actually, let's add our demo brick into our project's file. Demo. What's the demo? Yep, demo. Now we run this. It's make demo. This doesn't exist. So demo's one time. Oh, okay. I pasted something. Oh, kind of forgot to put that then. Break. Ah, sorry. Okay, we're back. We're good. So it makes me make demo. It's going to ask me what's my name, as usual. Totally. But now, obviously, before it starts to generate, it's going to say, are you happy? And I'll say, yes, I am. So now we've generated this node.md again, and it said you are happy. So that's sort of the concept of adding variables to your pregen. And just because why not, we can also have one to say if they're not happy. So we would just use the syntax to sort of convert this and say if they're not happy, you are not happy. Let's run this again. Dash this time. So it's a conflict, you overwrite that, and we'll go back, you are not happy. So that's the general concept of pregens. You can do a lot of things in there. And postgens, again, you can run scripts. I'm not going to do that. I'm going to do something a bit more simpler. I'm just going to say, let's just alert the user in, I guess, red. Let's say you did it. But this can also be as complex as you want. Postgen, again, loop, loop. Cool. Are you happy? Oh, yeah. And it's conflict, and now so it generated all those files, and now it says you did it. So that's sort of the general concept of post and pregens. They can be very, very powerful. A lot of my bricks use other bricks to sort of help it. So that's sort of that. We can go back into here, I guess. Oh, hang on. That's fine. Are we good on that side as well? All right. Yeah, no, I'll be there. It's only asleep. So yeah, so that's sort of it. I have got a repo with a bunch of bricks if you want to see more complex bricks and sort of what can happen there. Also, if you go to brickhub.dev, that's where you can sort of search all the bricks that are currently available. There's some on like AWS sort of creating the basics for that. A lot of stuff. That's very cool. So yeah, so that's sort of it. Any questions? Yes.
Yeah, on that. So you have like variables that you input that you can change for camera case. Can you customize that? For example, let's say I want to type an email there. Is that possible to add a rule for that?
Not through the Mason API yet. This exact question happened to someone else who did the talk as well. It's not there yet, but Felix, the creator, does recommend opening an issue on there to sort of keep your sort of thoughts on that, what it may look like. So I definitely recommend doing that if you are thinking of doing that. So yeah, that's good. Yes.
So why you create a company and why create another form of something like a middle?
I would not know the answer to that question. Yeah. Sorry.
Don't they do nothing?
I'm not sure. I haven't used those tools before, so I can really comment on that. I guess this is just this version of whatever that might be. Cool. Any other questions?
So like, this is like a templating engine, like what are like, people using it for?
So what we use it for at the Flutterco, for example, is sort of pretty complex startup projects like accelerators and stuff like that. I also like to use it for create like good features, like good feature structure and all the good standards for that. You could use it for like almost anything. Like you could really think of. So yeah, so that's the thing. Cool. If there's no other questions, is there any questions? Probably not go over there.
There's nothing online now.
It's just silence. Okay. So yeah, so I guess thanks for coming.
Thank you very much, David.
Just remind.
That's a big one.
How many people online?
3 billion.
Oh,
really?
It's a little bit smaller.
I know. Still, automation bricks. In general.